I'm Pang Wanjun. I'll talk about MOSFET and MOSCAP. MOSFET of capacitance of MOSFET. Oh, okay. First, we will talk. I'll talk about Ohm's law. So here is F is Q and E. E is E field, and Q is Coulomb, and A is um okay, acceleration. So and this is drift velocity is accelerate and capacitance. So accelerate and tau time. So q e over meter, and tau c is mu e, and that charge is q and a vd. A is area and drift velocity, and the n is mobility, and q is Coulomb. So charge density is q and mu e. This is the charge density is I. So current. So J is q and mu e. So we have to know about IDS. IDS is integrated of N mobility. So this is Q charge, channel of Q. This is area. This is cubic. So cubic per cubic integrated to per area. So Q minus 2 is okay. Q channel is minus Q integrated and N dx xy. So we have to know about this very small cubic. Okay, so this is the N, so per centimeter is cubic, and we can talk about Q is area of the surface, very top of channel, very small channel. So IDS is sum of this. So we can take about ID is WL mu COX VG minus VT VDS, and VDS over 2 square, but VDS is very low, if very small, and we can ignore this. This is the linear region of IDS, and this ID is a saturation region of ID. So there is no VDS, there is W over 2L mu COX and VG minus VT square. We have to remember this, very important. Okay, this is VD F MOSFET of ID VD curve. So here is linear region, and here is and here is linear region. Okay, 있는 것 같고. So okay. And this is channel length modulation. Channel length is the drain and source of distance. But if after pinch off, channel is attached to drain. But if bias is very high and after pinch off, and there is depletion region. So effective length is smaller. But in very long length, there is if not effective, but if length is very short and pinch off, so depletion region is more effective. So in saturation level, there is slope is more higher, okay, because of pinch of small length modulation. So ID is more higher, but this is not good because resistance is lower and gain is lower, okay, so this is not good. And this is NMOS ID-VD curve, and this is PMOS ID-VD curve. So and this is ID-VG curve of NMOS, and this is ID-VD, ID-VG, PMOS curve. This not same, but some symmetric of origin. Okay, this is IDVG characteristic. IDVG characteristic. This is IDVG characteristic, and a surface electron concentration is NC. This NC is exponential minus ECCH minus EF over KT, and so this is ECCH. This distance is here, ECCH, and E Fermi level of here, very small region. But this if this is shorter, and energy concentration, electron concentration is more larger, okay, because of this is basic, because Fermi level is more come closer and electron concentration is more higher, okay. So this is P sub, this is MOSFET, and P sub, this is P sub, and N plus source and drain is N plus, so there is depletion region. And this is energy level of drain gate source. But if plus bias in gate and low energy barrier is lower, energy potential is lower because plus bias. So but this is drain and source is equal, so no current of the channel. But if plus bias in drain and energy level is lower, so there is energy potential difference in source and drain. So electron in source is go to drain, okay, because of energy potential difference. So more bias in drain and more current is more current, okay. And VGID in J is Q and mu E. E is electron field. If electron field is VDS over VG, LG, length of gate, and VDS is more larger and E electron field is more larger, so Q and mu E, so J and I is more larger, okay? So in IDVG curve, they are more larger, and exactly ID VDS more less plus bias in drain and lower energy field, so slope is more lower, okay. And this is some diagram of MOSFET. So here front is channel and behind is back is P sub. So in gate have plus bias and potential of gate is much lower. So electron is here can go through the channel, but no current. But the drain have a plus bias and current has there is current, okay. Mobility is and electron mobility. Here is donor. So donor give electron and that have plus ionization. So that have charge. So electron much closer and push the hole. So there is, and if acceptor, there is a reverse effect. So this is impurity. This okay, and if Si have thermal energy and that has phonon vibrate, so that that has vibration, so scattering effect appear, okay, appear. But mu have harmonic average, so small effect is dominant, so that can have this graph. So this is mobility and this is thermal effect. So phonon scattering is impurity scattering is here. It's very much higher because of thermal, but phonon scattering is lower about thermal, so it goes through here, but and it goes down because of smaller effect is more dominant, okay. And so here is velocity saturation because of scattering effect. So saturation, velocity saturation, and velocity saturation appear and there is go down of mobility. Okay. There is different operation of MOSFET. If zero bias and it doesn't have channel, and that is enhancement, but it, zero bias, but it can have channel, that is deployment MOSFET. Okay. And I talk about MOSFET's capacitance. Okay. They have very many capacitance because of in MOSFET that have metal oxide Si only 3, but MOSFET have more drain and source. So drain and source can made capacitance. Here is deployment. So they have junction capacitance, and they have out gate and drain capacitance and mirror of same thing. Okay, so we can measurement of capacitance of about MOSFET. So that have three way of measurement. So first we have to know about total capacitance. So drain source and body have low and gate is high. We measurement of high and low between high and low capacitance. So here it is, and there is accumulation and depletion and inversion. So if accumulation, they have only COX because there is no depletion region, so only COX. So there is COX very high, and in depletion region, they have COX and depletion capacitance of series. So we can take C total of harmonic average of C total COX and depletion capacitance, so much lower. Okay, because of harmonic average. If inversion, they have some channel, so we can ignore the depletion capacitance, so go higher. Okay, and second way is drain and source is low and body is ground, so we can see diode in there and depletion in here, but we don't take a depletion capacitance. So in accumulation we can talk about here very low, because junction capacitance, there is capacitance of junction, so junction capacitance is very small, so harmonic aversion smaller effect is dominant. So here is accumulation, and in depletion region we can make we don't have this, so only COX. So here is much higher, and inversion there is very only COX. So here is. And last way, body is low and drain and source is ground and gate is high. First, accumulation, there is only COS, so high. And depletion, in depletion, there is COX and depletion capacitance, so much lower. And in inversion, we can see the junction diode, so much lower. Okay. And we can talk about substrate hole swing. Okay. So we talk about diffusion current. So here is IO exception QVG minus VT and KBT. So N is very important. So this is the VT ID VGS graph, and this here is very small. Very difference is small, but in the log scale there is very much deep graph in here. So here is VT, in here is I0, so we can take here, and here is okay. So this is the standby mode of MOSFET, and spent very low current, but in chip IC, in integrated circuit, there are very many tons of transistors. So if one MOSFET have very low, but tons of capacitor spend many current, so many power in standby current. So this is very useful in here or here, very important. If slope is looser, and we can separate standby and operate mode. Okay, so slope is megavolt per decade, and megavolt decade is much lower and good. Okay, low millivolt per decade is very good. Okay. N is in ideal condition is 1, but many effects so in okay, sorry. Okay, if this is such a depletion region, so here is the Fermi level is here, so there is electron, but in accumulation there is much more level can have electron, so much Q density is there. Okay, and that is small Vg, but there is much Vg, so Vg and Q, this is in IT1 and this QIT2. QIT2 is much higher than IT1, so derivative about Vg, and this is capacitance because C is QV. Okay, Q is CV. Okay, and this is, we have to talk about COX and depletion capacitance between this. Here is VCH, okay, so VCH is electron voltage divider. So here this is the capacitance of here. VTH is here. Oh, I forgot the VT. Oh, I forgot the VCH. VDD. VT. So this is N. And N is 1 plus CDF depletion COX plus CIT COX. CIT COX is here because depletion and trap capacitance is parallel, so we can only plus. So this is N. So this is N, and N is 1, and if ideal, they are no here, but we are not talk about ideal condition. So here and this and this is plus plus. So N can be much more than 1. So slope is loser. Okay, loser. So this is N is very important.